All right, so welcome everybody. Again, today's session is data confirmation. So kind of day 2 of 4 on our journey through the basic statistics within ARM. Last week, we really just gave a nice overview of what data review and the basic statistics that's run within ARM. So now today's session will dive into some of the tools we talked about for really the first step after you've put in data confirmation. And then we have 2 more weeks talking about data review and the AOV report. So with that, let me toggle over just to the presentation. This was the one slide of the presentation we covered last week. Just to recap kind of where we were at. And so we covered kind of everything last session. And after we talked about the real basics, we said as soon as you get the data into ARM, you're not quite ready to just jump into the analysis. We really wanted to point out that there is one step that's important to take with that data that's in the software, and it's really looking at the data to make sure it was put in correctly, and to just look at the assessment itself to make sure that what is in there is accurate and makes sense. So we talked about outliers, how that really it really messes up those assumptions of AOV when you have an outlier present. So trying to track down any kind of rogue values that are in that assessment before we go to the analysis will make sure that our results are useful for us. And so that really try to encapsulate this, all these points into really one step. And I've kind of just called it data confirmation, to look at the assessment, look at those values, depending on where they came from. If you just wrote them on a piece of paper during the assessment and now somebody sat down and transcribed them, of course, there's a chance of a typo or things like that. And then there's also just what actually occurred in the field or at your trial site, if there is something unusual, to try to identify those types of things before we start to analyze and look at what happened from a statistical standpoint. So that's really the target today. And that's all the slideshow I want to show. Let me close that because we'll spend the session here in ARM. So I have an example trial open, and I have one assessment. We'll just pretend I just finished recording this assessment. And so I've got a variety of values filled in here for a percent area. So kind of talking through, I'll kind of go through, I guess, the order, kind of the recommended order of the tools that we have, kind of logically maybe of what to look at and when. So the first item, I guess we mentioned last time, was the acceptable range of outcomes. It can be useful before the assessment takes place, to just take a moment to consider what would be a reasonable value. What would be a reasonable range of values that you would have for the particular assessment. And that can be helpful then when you're actually taking the notes, that if you see a value that is unusual, that can be a good way to catch those things even as you're taking the notes. I'm just noticing that one of my fields I want to make sure is visible here, because part of that process then, so in my case, I have a percent area. So the assessment that we're doing is maybe looking at the greenness of the leaf, to see if there's maybe how much disease is on the leaf of our plant, or something like that. And so the percent area would, naturally have a limit to it. That obviously we can't have over 100% in our area of a leaf, and maybe we would even have kind of a general idea of what we would expect to see. So that can be important to have ahead of time, or kind of wanting to validate our numbers that we have in our column. We also have a data range capability within ARM. So next to the rating unit, there's a minimum and maximum fields. These are somewhat new within the last year, I think, within ARM, and these can define the minimum and maximum valid values for your assessment. So in my case, it might be logical to say, I really can only have between 0 and 100. And when I put that in, now ARM will check either as I type in my assessments, or since my values are already here, it checked all of my values to see if it fits that range I just defined. And in my case, I kind of have a planted value here that exceeds that range. So I have 120 in one of these plots, which we just said isn't valid. So that's a great way to catch that either as you enter in the value, a great way, even if it's just a typo, to make sure things don't get put in incorrectly, or to kind of check over and make sure that the values that are there are logical. I'm going to cancel on that. We're going to kind of leave that there so we can catch that later on. But that minimum and maximum value there, you can hand enter as I just did. If you look at the rating unit, there are some that have those filled in. So if you're doing an index scale to 0 to 5 or something like that, ARM will have that automatically filled in and will be in use automatically as well. So some units here kind of have that already part of it, but you also are free to fill that in if that would fit the type of assessment you're doing. So that's kind of a precursor, either before the assessment is done, or kind of one of the first things once the data's in is to consider what even makes sense. What values would we be expecting here to kind of set the stage for looking at those numbers. And yes, you can. So question of whether this is possible in the protocol, you certainly can. So if you're filling out the assessment headers in a protocol, there's no place for data in a protocol, but this header section is available. So if you're wanting to fill in the assessments that should be done by the trialist, that minimum and maximum are there. So that's a great point to put in that range when you're planning that assessment. And that can be really helpful. Then for all of the trialists putting in data, they'll have that same feature. Like I said, if we put in I'll just pick random numbers 5 and 15 here for this assessment. And so when something's valid, it's fine. If I put in a 25 that's outside the range, it'll catch immediately. So I won't proceed. I'll be stopped right away to see that, oh, I typed in something that's not valid. So that's a great point to utilize that even in the protocol to make sure everyone has that information. Great question. All right, so next feature, I guess, that we can look at, assuming here that we've filled in the data, what we will use is over here on the properties panel. And if you don't see your properties panel, it might just be hidden. And you'll find that then all the way to the right, on the very far right side of the assessment editor, there's properties. If you click on that name, then there's a little pin button to make that stay visible for us. So once you pin that down, now I can click around and it'll stay visible. And I am going to go about halfway down into this tools section. And there's 3 buttons, and I'm actually going to work my way up. So the last one here in this list, assessment map. Real quick, before we show this, there was a question about protocol writing. If you can create a transformation or a calculated column in a protocol. Right now in a protocol, the menu item, the tools transform, is disabled. So there isn't a way to create a calculated column in a protocol because there's no data there yet. There is a way to accomplish that, though, if you have a typical transformation that you would want, and that's using an SE file. So you could define the and somebody else, perfect, has that answer using your SEs and planning those in your SE definitions. Basically, you could in a trial create the calculation you want, and then use save that transformation, whichever columns descriptions that you want, into an SE file, and then you can load that in a protocol, and the transformation will be there. So good question there, as well as ways to really automate some of that and bring that into a protocol so everyone's doing that. Great question. All right, so here on the screen, we have that assessment map. And basically what we have here is our trial map that we would typically view our randomization, but instead of coloring by treatment or by replicate, we actually have basically a heat map, if you will, of all of the assessment values for each plot. So ARM takes the smallest assessment value and the largest assessment value, and then takes that range and splits it up into at most 10 different shades of this green color. And so then each individual value, like this plot 101 here, has the value of 10. So it's shaded according to that range. So the lighter the color, the lower the assessment value. And a dark green or almost black here is the largest values in the assessment. So right away, we can see there's not a whole lot of difference. Most of it is light, except for one value. Plot 904 is very, very dark, and nothing else is particularly dark. So that's one really quick way to spot an outlier. In this case, there's a value really, really high. The flip side, we could have everything be really dark except one really light plot. Could also be the same situation where there's something really, really small. In this case, we have something very large. And so that's a great indicator that maybe we should look at what that 904 is. So if I close and I can scroll down and find plot 904, and sure enough, we kind of already knew that there was something weird in this column. There's that 120. So all of the rest of these values are, 25, 20, 10%, things like that. And we have this huge 120 that is quite unusual. And in fact, we talked about the percent area. We know this actually isn't even possible. It has to be a wrong value. So then this is where it's going to kind of depend on, what's the best action to take. It's really going to depend on a few different things. Number one, when are we reviewing this data? So if we already had somebody write down on a piece of paper all the values, and we just put this in on the next rainy day, now it's it's been 7 days, it's been a week, it's been 5 days since we actually took the value, there might not be a whole lot we can do. We can squint at this 120 and say, I know it's not right, but we can look at that piece of paper and see, did they write down 120? Is it smudged? I lost that paper already. I don't know. We might be in trouble. On the other hand, if we are actually still in the field because we're using something like the tablet data collector or ARM mobile, and we are still at the trial site when we found this weird value, the great thing is we could just walk back over to plot 904 and take a look. And then we can make sure that we know what actually happened. In this case, obviously, it's not 120. It can't possibly be 120. But do we know whether it's a 12? If it's a typo, is it a 12? Is it a 20? Is it a 10? It could be any of those. So you don't just want to guess at what you have. If you do have a way to confirm that, maybe like we said, we're actually out in the field, we can go confirm that it's supposed to be 20 and it was just a typo, then that's awesome. Now we can just make that adjustment and we know we have the right value. You don't have that luxury, you're looking at that and you really don't know what that could be, then really I think the best thing you can do would be to use the damaged marker. So we can throw out that value. It's obviously not ideal, but as opposed to just making it up or guessing, might not be great either. So kind of a balancing act. Depending on your situation. But if we decide I can't use this 120, I know it's not right, or I have no way to guarantee that it's right, I need to just throw it out. What you can do is on the properties panel, we have this section here for assessment. And specifically, there's a box that says damaged. So if we turn that on, when we're clicked into this 120, then you'll see that there's a red line that gets marked through that 120. So ARM will treat this like a missing data point when we do the analysis. But the nice thing is we can still maintain, we can still have the recorded value for whatever that may be worth. Certainly there's also a spot in ARM for a comment. I think especially if you're using a damaged marker, it may be wise to put in a comment as to why it's damaged, or thrown out. I guess we wouldn't have to necessarily say it's damaged, but maybe it's thrown out because 120 is not possible. Whatever the rationale is for marking that as damaged, having that comment there can be really great if someone else is then looking at this trial in the future and maybe not totally sure why did we have to throw that out. And so having that rationale can be really helpful to document the purpose of why that's there. So we have that option on the properties panel for whichever value you're clicked into. In my case, we're going to say we feel great. We're using a tool where we're doing this in the field, so we can confirm it is 20. So in my example, we will just change this to 20 because we confirm that is the case. But a few different options. Now, if I click on the assessment map again, you'll see it looks a little bit different now that we have a more reasonable value in that 904. Suddenly it's looking a little more interesting because we don't have that extreme value, making everything else seem not terribly interesting. A couple more functions of this assessment map. This really is the same trial map that we have. So if you're familiar with some of the options that are possible in the trial map, we really have most of them available here for us as well. And so one of those here is the show true scale. And so this will, instead of just displaying a little square to represent each plot, it'll actually take your plot dimensions that you have in settings for the trial and try to draw the map to scale. And that can include any alleyways, things like that, to really give a good picture of really what this looks like in your trial site. So in my case, you can see it changes quite a bit. These plots are actually fairly long and not terribly wide, as opposed to just the little squares that we were looking at before. And so this can be really helpful for, just kind of the overall spatial effect of that assessment. You can kind of gauge any patterns that might be there that otherwise might not stick out when you're just looking at a list of numbers. So you can catch where maybe right down the middle of the field it's all darker than normal, or in one corner it's really light. Things like that just would pop out as a visual compared to just looking at numbers. I think can be really helpful. We do also have color by current treatment. There's a box down here you can turn on, or if you click into a plot. So here I'm going to click on plot 101. And when I do that, it highlights, basically turns off all of the other plots except for treatment 3. So then I can compare in my different replicates the performance of treatment 3. And I get an idea of how consistent it was. And then I can just continue to go down. I like to go down my first replicate and just click into each treatment and get a sense of how consistent maybe its performance was. Here treatment 1 looks very consistent. Treatment 4, not so much maybe. Pretty dark in the middle here, but up in this corner, treatment 4 really was pretty low, and so on and so forth. There's kind of that darkest one there that really stands out, but there's a lot of low values for treatment 5 as well. So that's unusual. Again, maybe worth a check if we're out there in the field to make sure that 203 is correct, or maybe it's something just to consider, well, that treatment 5 was quite variable compared to the other ones. Just kind of depends, of course, on the study. A couple of questions here before we get too far. First one, asking if there's an option to keep the positional average of the data point other than marking it as damaged and throwing that data point out. Yeah, definitely when you mark as damaged, here, let me just close that so we can show when we were looking at this value and we marked it as damaged. Tossing that out, definitely has a big impact on your analysis, especially if you don't have many replicates, or just in general many plots in a study. That can definitely have a big impact on your precision and what you're able to do statistically. So it definitely not something you just immediately, well, that's a weird number, just make it damaged. I definitely agree. You want to put thought into that. So I think the question is, back when we had this 120, and we say, well, that's wrong, but what can we do? The analysis will adjust for a missing data point. So we won't be totally lost if we throw out this value. I'm going to go into the print reports real quick just to show a couple of options when you're doing the analysis. It's going to depend on your analysis method. The modern one is least square estimation. That one is the better one to choose. And there's an adjusted mean. So if you do have a missing data point, so you don't have balanced data, in our case, looking at treatment 4 is going to have one less data point than the others. So to balance that out, the analysis can kind of, as hinted, take into account the rest of the average for that treatment, in addition to the replicate itself, and try to make an adjusted mean. Try to make an estimate for what that value probably would have been. Obviously, it's not going to be perfect, but it's definitely better than being totally out of luck. So if you're using the least square estimation, then using that adjusted mean is a recommended option so that it adjusts for missing data. So that's a good compromise, if you will. It still, it still impacts your precision a little bit, but it's definitely better than obviously just having nothing at all. If you were using the traditional AOV, not recommended, but if you are doing that, then in the general summary, there's a missing data estimates to tell ARM which of these two methods you should use. There's the Yates, and then there's just using the average from the other reps of that treatment. So those are your options there when you get to the statistical side of what happens with that missing data point. Let me change that back to what we were looking at there. Next question on the assessment map, if you can delete the untreated from the map. So certainly if you have an assessment where the untreated is significantly different, let me check. We do have the ability in the action codes field, which is hidden at the moment. Let me find that. There is EC will, in the analysis at least, toss out the untreated check. So it will not include that in the analysis, especially if you're doing like a % of check or something like that, where the check just isn't part of the focus for the analysis. But I don't remember if the assessment map will reflect that or not. It does not. So it is still going to include the untreated. I guess one workaround you could do, because I think it'll ignore missing data points. So if I were to sort by treatment, oops, sort by treatment, if I mark all of those as damaged, let me just see if that'll actually work. Because I think if it's damaged, then on the map, it is ignored. So that'd be one workaround if you want the untreated to not be drawn at all when this map is created, then you could mark each of them as damaged. I'll do that a little slower to show how I did that. I just sorted by treatment. So that way I had all of my treatment one, if treatment one's my check treatment, next to each other. And then I could just drag and select all of those values at one time. And then on the right, when I turn on or turn off the damaged marker, then ARM says, hey, you had multiple data points selected. Are you trying to turn on or turn off that damaged marker for all of them at once? And so I said yes. And now in this case, it turned them all back on or would turn them all off all together, save a little time. So that would be the workaround to have the untreated not used in this map. Finally, a question about these boundaries. So this is automatically calculated by ARM. So currently we don't have an option to customize that. It is a request I've heard in the past. And I think we've had some brainstormed ideas on how we could either open that up to choosing your own calculations, or if there's some way to instruct ARM and maybe have different types of ways ARM breaks this up. Currently, it just looks at the lowest, the highest, and divides by 10. But of course, you could maybe want to care a little more about certain values and less about others, and things like that. But currently, the answer is no. It's just kind of automatically generated. But great questions. And a nice suggestion for paired checks. That's a question that comes up every now and again. So I'll take note of that as well. All right, I think that covers everything with this assessment map. Really nice tool. I think it's one of the most well hidden. There's, it's really only found here on that properties panel. So I consider one of the highest value relative to how obvious it is to find it. It can be a little hidden, but very useful. And as I mentioned earlier with the data collection options, if you're using the tablet data collector, of course, that is running ARM itself. So everything we do today is available if you're doing the tablet data collector, because all of the ARM software is there. So everything is available to you, including this. ARM Mobile, our mobile app, isn't quite the same. There's fewer features there, but we do have an assessment map. It's been a little bit since I've been in the app. I can't remember exactly what we call it, but there is a function just like this, that assessment map functionality to make a heat map, and you can zoom in and look at the individual values to be able to detect those things that really pop out. I think we call it assessment review. I think is the button there that you do in the app. So really big, I think, to be able to visualize that assessment. Something that'd be very hard to do if you're living in Excel or writing it on a piece of paper. But being able to use a computer to visualize really, I think, ups the game of what you can do looking at those values. All right, the next tool, right above the assessment map, there's a button for the Box-whisker. So if we click on that, it immediately brings up a graph. And this is the Box-whisker graph for the data column that we were clicked into. We'll show just a couple of the quick features, the biggest features for the graphing. This is the general graphing tool in ARM. There's quite a few things you can do with it. We'll kind of focus just on the high impact ones for this graph. But the first one I want to do, you'll notice that these treatment labels are pretty long. So we really don't have much of a graph here. So in the corner, there's a box to show your x-axis labels as a legend. And that's really nice. As you can see, it gives us a lot more space to have a graph, and then just puts those treatment labels over to the right. So hopefully that makes this graph a lot more readable for us. So if you're not familiar with a Box-whisker graph, we'll just kind of run through how it's created. So these are, of course, each treatment we're looking at, and how it is drawn. We have the Box-whisker starts really looking at your data points that you have in the assessment and splitting it into percentiles. So the bottom of the box is the 25th percentile, and the top of the box is the 75th percentile of the data. And you can see these little dots here vertically. Those are the individual data points. So hopefully that helps to visualize what that percentile is. Really 50% of the data points from the 25 up to 75 creates the height of this box. And then the whiskers extend out to the rest of the values that you have, provided they aren't outliers, which we'll get to in a minute, that there's an outlier calculation, but the whiskers kind of extend out to the rest of the regular values. So and then within this box, we have two different lines. The dashed line is your mean. So that would be your treatment mean. And then the solid line is the median. So the median is your 50th percentile, so kind of right in the middle of the box height. And then that mean, it can actually be turned on or off in your options, but then that mean can kind of tell you something relative to where the median is. It can give you a sense of the skewness of the data. So here they're pretty close, but if I move over to treatment 4, for example, you can see the median is quite a bit higher than the mean. So the mean's pretty low. And that tells me that there's some skewness, that there's maybe one or more than one assessment value that's a lot lower than the other ones, giving that skewness effect. Sure enough, and you can see just looking at those little dots, we have one right at 0, and the highest one is at 20. So we've got a lot of values that are lower, kind of giving that skewness, as opposed to something like treatment 1, where they're pretty close together. So it's fairly balanced, not a lot of skewness in that treatment. So that's kind of one of the usefulness for looking at those lines and getting a sense of that distribution of each of these treatments. Some other things to look at: the height of the box. So we talked about the percentiles. That can give you kind of a nice sense of the variability in each treatment. So we really don't care if this is a tall or a short box. We wouldn't look at the number of how much it really spans, but just relative to each other. So 1 and 2 are pretty close to each other. 2's maybe got a little more variability, but they're all pretty close to each other, except, well, treatment 3 is quite a bit shorter. So there's more consistency, less variability in treatment 3 than the other treatments. So last time we talked about one of the assumptions of AOV is homogeneity of variance, meaning that roughly each treatment has roughly the same amount of variance as one another. Since in our analysis, we are taking apart the variances and investigating that, that's really important to make sure that that assumption is met. So this is kind of one of the first glances you can get to get a sense of whether that could be an issue or not. And I would say just roughly looking at this, there could be some issues, since treatment 3 is fairly tight and the others are a little larger. But we'll see next session. We can run some statistical tests to know for sure, or at least increase our confidence of whether it's an issue or not. But again, just kind of getting that sense of what we're looking at, kind of like we did on the assessment map as well when we were doing current treatment, getting a sense of that consistency in each treatment. Another thing to look at is the outliers. We mentioned that once, and here in treatment 3, there is actually an X up here. So you'll notice that the whisker here that extends out, it only extended to this 15 value, and it didn't go all the way up, even though there is a data point up here at 25. So the Box-whisker has an outlier calculation to it. And essentially, you would take the height of the box, multiply that by 1.5, and if there's any data point that is more than that 1.5 times the height of the box away, then that would be considered an outlier. So just comparing treatments 2 and 3, there's obviously a pretty high value here. There's a 40 up here, but that whisker goes up to that 40, which says it's not calculated as an outlier. Well, and why is that? Well, this box is quite tall. So it's still, if you had your fingers on the screen, you could kind of estimate and see that the height of this box would be up here. And so it definitely fits within that height that you can imagine. 1.5 times this height gives us a lot of leeway. It'd be way up in the 60s or something at least, I think, before you would get an outlier. Whereas for treatment 3, there's a lot less variability in these other values. So the height of this box isn't very tall. And so if you took this height of this box and stacked it here and another half, yeah, you'd end up right about here. So we can see that that X falls outside of that range. And so it is considered an outlier within the Box-whisker realm. Kind of the important thing I think to consider is not just to immediately say, oh, it's an outlier, or we should throw it out. But again, just kind of like we did on the assessment map, it gives us something to look at. Let's go and review that plot 705. You can see if you hover your mouse over that X, it tells us what plot number that data point is. So we could then close our graph and go look at that 705. Let me sort by plot number so we can find that again, 705. And just looking at the number 25 certainly is within our range of 0 to 100. There's no obvious typo there. So it doesn't stand out by itself, but it stands out within the realm of that treatment and how that treatment performed. So that a really nice case of using multiple tools can really help us find and investigate some of these values that might not just jump out immediately. We started with the most obvious, that 120, but there can be some more things to find and look at. But just because it's an outlier doesn't mean let's immediately throw it out, let's not use it. But it's just important to consider if that value is right, and make sure we did transcribe it correctly, or make sure we, if we're still in the field, we can go back and take that assessment again and kind of confirm that that is correct. We didn't just get going too fast or did something inconsistently. Make sure that that's correct. Because just because you have unusual data doesn't mean it's unusable. So I think it's important to know that it's definitely more of a science to looking at those values and not just a yes, no, it's an outlier, throw it out, keep it. But kind of using your expertise and understanding what that assessment is and what it means to make a good decision. So again, that was the Box-whisker. And just to show the graphing functionality, there's an options button here that will open up the graph options. And there's a lot of capabilities. We can spend a whole webinar on graphing and the different options that you have. So we won't dive into much, but you can control a lot of what is on the graph, how it's displayed, things like that. For if you wanted to use this in a presentation or something like that, you can customize it to the way you want, and then use this clipboard button down here, or there's also a shortcut clipboard button up here. And that basically just takes a picture of what you see on the screen. And so it's real nice to throw into a PowerPoint presentation, throw into a Word document, whatever. Let me zoom out and you can see that, and then it's just exported as a picture, just the way we had saw it on the screen. All right, so that is the Box-whisker. If we had more than one data column, and I should have shown this on the assessment map, you can actually kind of toggle and look at the next column as well. There's a button here, next and previous. It's not going anywhere for me now because I don't have any other columns with data. If I real quickly just put some numbers in here, it's obviously not going to be anything exciting, but if I had numbers here, so I had more than one assessment taken at one time, then in the Box-whisker, I just have to press next column, and you'll see it'll change to data column number 2, and we can look at that assessment as well. Can go back to column 1, and the very same thing I should have mentioned on the assessment map too. So there's a next and a previous column. So now we're into column 2, and you can see I've only got a few plots because I haven't recorded all of them, but that's a good way to repeat this process across multiple assessments as you're taking a look at them. So those are the two big data confirmation tools. We've got the AOV means table button here. I don't know if I'm a huge fan of that right away. I guess, it's a way to see treatment means if that's important to you. But to me, that's maybe a little early to be getting any real analysis. As we mentioned, there's still a data review. There's still a process that we'll cover next week with really preparing the data, checking for the assumptions of AOV before we really do an analysis. So a little early for the AOV means, but it is there. And basically what this button will do is whichever column you're clicked into. So if I'm in column 2, then when I click the AOV means table, it's going to generate the AOV report for the assessment column I'm clicked into, and any of them to the right. So here I just had column 2 clicked into, and I don't have any other ones defined, so there's just the one here. So, and it'll just take your current options as they are in print reports, just to bring up something quick. Like I said, I'm not sure that that's really the best thing in this data confirmation step. All right, we looked at the damaged marker. I guess the kind of the one last tool that we kind of fit in this vein of data confirmation. Currently, it's on the column properties. So here we're in the regular properties here. I'm going to unpin this to hide it. And then we've got several of these here, and we have a column properties panel. And this used to be kind of the place to go for the data review. So we would be showing it next session as part of the data review, but we've made some newer tools that have more modern statistics behind it. So we're going to ignore a lot of this, but I think there's still a couple of components here that could be useful. So just real quick to point those out on the column properties. The very top here has just a brief summary of this assessment. Specifically, this is original data. If we had changed a value later, I think it marks it as changed. All the statistics gray out until we refresh it, things like that. Let me undo that to keep the value the way it was. And then there is just a recap of some information about the assessment. So here we have the smallest value and the largest value in this assessment, 0 to 65. If we had that 0 and 100 range, then it'll have the min-max entry to make that clear that there is a limit applied as well. So things like that, just to give an overview of what this column is about. Again, I think skip over the statistics portion. We'll really hammer that next time. And the fix here, that's the old routines, but there is an outliers calculation. That'd really be the one reason I think to come here still is this outliers tool. So we talked about an outlier in the Box-whisker realm. And so this has that very same calculation. So if I wanted to find if there's any outlier values according to the Box-whisker calculation, I would just choose Box-whiskers and would click Find Next. And so that will bring the cursor to whatever value is considered an outlier. So if I go back to plot 101, wherever you're at, and then say Find Next, it'll move me, in this case, to plot 203. It says, all right, this is calculated as an outlier according to the Box-whisker definition. If I press Find Next again, it's not going anywhere else. So there's only one value that is considered an outlier. A couple other ways that you could calculate an outlier, and this really would be using standard deviation. So plus or minus 2 standard deviations from the mean, or plus or minus 3 standard deviations. And so again, you just select whichever method you want to use and press Find Next, and it'll take you to the next plot. In this case, that 65 seems to be the only one there for the 3. Plus or minus 2 in theory would probably give us more values as potential outliers. Let's see if it finds anything else. Yep, now it brings us down to 801 and then back to that 203. So now there's 2 values. So as you can see, depending on how you want to define which calculation to tell you whether there's an outlier or not, you may get different results. And so just think, wanting to make the decision of how do I want to calculate and realizing the implication of that. So just a quick comment on like the standard deviations. If you had a perfectly normally distributed plots, your data was totally perfectly normal, bell-shaped. In theory, if you had 100 data points, plus or minus 2 standard deviations, you would still see, is it 97.5, I think is how many fit inside 2 standard deviations. So you'd still have 2.5. So you'd have two or three values in a perfectly normally distributed assessment. You'd still have 2 or 3 that would pop up in this definition. And then 3 standard deviations, I think is that 99% in the normal distribution falls within 3 standard deviations. So you'd still have 1 outlier, even if the data was perfectly distributed, but you had 100 points, you'd still would end up with 1 that would probably pop up here. So realize that just because it tells you there's an outlier doesn't mean immediately throw it out, but just gives you something to look at and think about. Is this value reasonable? Is this value right? And I guess real quick, since we were talking about the outlier calculation, there is also an outlier calculation in the column diagnostics. This is the new tool we're going to spend all next week on with the data review, but there is also a different, so kind of a 4th different outlier calculation that shows up on the diagnostics. It's very conservative relative to these other 2 outlier options, or other 3 outlier options, in that it really won't find an outlier unless it really is an unusual value. I don't remember all the details of the calculation that goes into it, but it's looking at the residuals and really, again, really conservative to make sure that if you do have an outlier, it would pop up on the column diagnostics as a separate little panel and say that there's an outlier. But it's very conservative. In fact, typically I try to rig up some numbers just to demonstrate all the features, and I have a very hard time making an outlier to show up here. So it really does a good job of only if there really is something quite unusual hidden in there, does it actually pop up. But again, just to recap, I guess here, the whole goal really for these outlier calculations and some of the tools we've looked at is really just to give a good quick once over of the data that's been entered to make sure, number one, it was filled in correctly, there's no typos or things like that. And then number two, that there aren't any outliers that don't represent what actually happened in the field at your trial site. Naturally, some weird things can happen. You may have an unusual value that is 100% true and totally is what occurred, and definitely that needs to stay there and be part of the analysis. But we're trying to catch anything that is unusual and not correct. And so that's really this data confirmation step. And once we're done, now we've looked at these tools, we can feel really good that this assessment is representative of what happened. So now when we move on to data review and start to look at the analysis and the results, we can feel good that what we're going to see is true. And we can draw some conclusions from that with confidence that things are what they should be. So that will do it, I guess, for today's session. If anyone has questions, I can stay on for a little bit, but we kind of reached our hour here. So I'd like to thank everyone for joining and the great questions throughout the session. And hopefully we'll be seeing you next week as well.